Okay, welcome to segment two. Just a reminder, by the way, it really is way better if you get the URL and put it on full screen. Looking at things on tiny little screens, you might be used to it, but it's not nearly as effective. Okay, so go ahead and do that if you haven't already. Um, this part here is about precipitation. Precipitation, as you already know, there's, in the steps of the water cycle we did here, there's evaporation, condensation, and then precipitation, where it falls down, right, in the form of rain, sleet, hail, snow. And most of these, you already got a pretty good idea about what's going on. But let's kind of get into it first anyway. So precipitation. Okay, the most familiar type of precipitation, of course, is rain. Write that down, please. Have your notes ready. Let's be doing that. Now, this is one reason why the little screen doesn't work so well. The average condensation size, this is a super magnified view. It's 0.0002 millimeters. That's the condensation nucleus. That's the sort of the germ, the little seed of a raindrop. Okay, basically, if you have a little piece of dust or something like that, or what we would remember when we put that little bit of smoke in the bottle to make the clouds form, that really does help the clouds to form because the water droplets will start sticking to that, and then they'll start sticking to each other, and then you get to a cloud droplet, which is 0.02 millimeters. So this is so small you can't even really see it. It's so tiny, tiny, barely almost looks like a tiniest little dot, right? If you could see it by itself. And then a raindrop is about 2 millimeters. Now, 2 millimeters is really small, but in I've always thought it was kind of funny. I like this diagram. Imagine a giant raindrop. What if it rained and all the rain came down just as one big giant drop and slambo? Oh, that would be terrible. Oh man, look who got hit by the raindrop. Anyway, it doesn't work that way. It comes down in millions of little tiny droplets. But there you go, rain. And there you can, I always think it's kind of interesting when you can see out in the distance and you can see that it's raining. You can tell often when you're looking in the distance. That would be a nimbostratus cloud. And so the raindrops sometimes can get bigger, especially in a thunderstorm type of situation. That's rain. Now, snow, we're familiar with, this white stuff, right? A lot of times raindrops, when they start out up in the upper atmosphere, they start as snow. And so then they melt on the way down. But snow can't melt on the way down or it won't be snow anymore. And snow, of course, is fun for, going skiing and, oh no. Anyway, what happens with snow is you have the snowflakes form in the upper atmosphere, about 3 kilometers high. It's about a mile and a half. And then as they fall, here's the temperature, right? It gets warmer, warmer, warmer as you drop, but it never hits 0 degrees Celsius or 32 degrees Fahrenheit. That would be the melting point. If you're going from in the melting direction, freezing point if you're going the other way. And it just stays frozen all the way down and it lands as snowflakes. So, but here's an interesting thing about snowflakes. Remember when we learned about the different ways that water can change evaporation and condensation? Deposition, remember deposition? Almost nobody knows about that one. Now, the only way you can have a crystal shaped snowflake is if you don't have a water droplet freeze, it wouldn't be crystalline like that. The only way you can do that is that the molecules attach one at a time. It has to go straight from a vapor right to a solid in order to be a snowflake kind of shape. So this idea of deposition is really unknown, but it plays a big part in what really happens on this planet because a lot of rain starts out as snow and a lot of snow starts out as snow. So anyway, deposition really is one of the most prominent changes of phase in our atmosphere. Okay, so it starts out with tiny little crystals, and depending on the altitude and stuff, I'm not going to make you read that slide. These are like diagrams. It's supposed to represent individual H2O. Here's the O and two H's. And they start sticking together and they form like a hexagonal crystal. At a molecular level, the molecules form little hexagons And then they build onto it. So write that down. Hexagonal means six-sided. 1, 2, 3, 4, 5, 6. So it's a six-sided crystal. As the molecules start forming and sticking together, and they get bigger and bigger, and they start growing into larger shapes until they start getting that hexagonal snowflake shape. Now, this is a tiny little snowflake that's magnified, and the photographer here, by the way, is a great photographer of snowflakes. Really good use of lighting and color. But you can have all these different varieties, and it's symmetrical on each of those six sides because it depends on how it starts out and what the temperature is. The molecules will attach one at a time in a similar way on this side as they will on that side. So you get that same kind of shape. And you've probably heard there's no snowflakes that are the same as each other. Well, there's billions of types of snowflakes, but every time you have a major snowfall, you probably have trillions of snowflakes. So some might be pretty darn similar, but you're not going to find any two that are identical, just as a practical matter. So the variety of shapes of snowflakes is just remarkable, and they are very, very beautiful. And it all depends on the humidity and the temperature and the altitude. You can have all these different varieties of snowflakes. And notice they're all six-sided, and that's because of the way that the molecules of water start lining up just when they first start attaching. Okay, and then when you have the trillions of snowflakes, you can have a whole snowfall, and it's all white and beautiful. Now, sleet is one that people don't understand sleet very well. Of all the types, a lot of people think sleet is like slush or sloppy ice, whatever. No, what sleet is these tiny little ice crystals. A lot of people will see a sleet and they'll go, oh, it's hail. That's not hail. It's sleet. And now what sleet is it starts out as snowflakes, but you have a warm layer of air, and then you have a cold area of air down by the ground. So the snowflakes melt, and then they freeze again. So these are like basically raindrops that have frozen when they fall. And this will happen in a warm front, basically, as the temperature, it gets warmer and warmer. They melt. You have this shallow, warm area, higher altitude. That's, by the way, it's called an inversion, temperature inversion, when you have warm over the cold. And then they freeze again before they hit the ground. And often that'll happen in a warm front. So again, here's a diagram of a warm front when the warm air slides up. Sorry. Edit that out. Slides up on a colder air mass, and you have snow up here, and then it rains because it melts, and then it freezes again into ice pellets. And that's where you get sleet. And you've seen sleet before. I saw sleet just a few weeks ago. Now, freezing rain is a whole different ball game. A lot of people think, oh, well, sleet is like freezing rain. It freezes on the way down. No, what freezing rain is when the raindrops hit the ground and instantly freeze. Sometimes they can get what's called super cooled, where they're below freezing temperature, but because of various reasons of the conditions that they stay liquid a little bit more. It instantly turns to ice as soon as it hits the ground or the twigs of a branch. Some people consider this some of the most beautiful kinds of things. You ever seen this where it's like a crystalline forest where all the branches and everything are all you got the frozen ice on the little twigs and on the grass, and these deer are frozen in place. No, I'm kidding about the deer. The deer aren't frozen. But anyway, it can be like a beautiful wonderland, really. Here we are in Arizona, where you had this huge ice layer formed around the cactus. I don't think it did the cactus much good. But anyway, that's called freezing rain. And what happens here is, it starts out cold, like snowflakes is normal. And then a deep warm area where it's all raindrops coming down. And then right before it hits the ground, it gets down below freezing. And so instantly it just freezes, boom, as soon as it hits, and that leaves an ice layer. And so that could be dangerous in some ways. Like if you have freezing rain on airplane wings, that makes the wings shape different as well as weighing more. And so they have to de-ice. You might sometimes hear about de-icing of the airplane wings for before you can fly, and it causes delays and stuff in airline flights. Uh, so anyway, freezing rain. Also, here's a pretty bad case of freezing rain. This is in the shore of Lake Michigan is where this happened. And I've always wondered, man, what if there was like some person sleeping in there and they wake up, oh no, I'm stuck, help, let me out. Anyway, this is freezing rain encased the car. That's about the worst case of freezing rain I've ever seen. Now, one thing about freezing rain I will say is do not drive in freezing rain. Look at that. It's just a sheet of ice and you will get no traction at all. So it's really dangerous for traffic and things. It can also, the weight of it can pull down branches of trees and stuff. And here, this is, look at this. This is way back in the olden days. They have horse-drawn buggies and stuff. But this is when they first started having power lines and stuff. Well, the weight pulled down the power lines. And if you think that only happened in the olden days, nope, it can happen in modern age too. This is freezing rain, got on the wires, and it made them weigh so much it just pulled the towers down and they fell like dominoes. And so freezing rain can actually be fairly destructive. It's just because of the weight of it and the slipperiness of it.